Have you ever wondered what data science is and why it's so important? Welcome to the intriguing universe of data science, where curiosity meets technology and patterns emerge from chaos. Data science is an interdisciplinary field that marries mathematics, statistics, computer science, and domain expertise to weave a tapestry of knowledge and insights from vast amounts of data. It's like being a detective, but instead of solving crimes, you're uncovering the hidden stories within the data. Using scientific methods, algorithms, and systems, data scientists dive deep into both structured and unstructured data, swimming through rows and columns of information to find valuable insights. This process isn't just about numbers or codes, it's about understanding the world better, making more informed decisions, and creating new opportunities. In simpler terms, data science is about obtaining, processing, and analyzing data to gain insights for various purposes. So let's embark on this journey to uncover the magic that data science brings to our world. The first key aspect of data science is data collection and storage. Let's envision data as the fuel that drives the engine of data science. Without it, we wouldn't have anything to analyze or gain insights from. So where does this data come from? Well, data is gathered from a variety of sources. It could be databases, Excel files, text files, or even real-time data streams. We can also use APIs and web scraping to collect data. The goal is to gather as much relevant data as possible to feed into our analyses. Now imagine you've just returned from the grocery store with bags full of fresh produce. You wouldn't just toss everything onto the kitchen floor, would you? Of course not. You'd carefully store each item where it belongs for easy access when you need it. The same principle applies to data. Once we've collected it, we need a secure and efficient way to store it. Storing data may sound straightforward, but it's actually a complex process. We need to ensure the data is stored in a way that allows for quick retrieval and processing. This is crucial because it affects how easily we can access and use the data in the future. Think of it like a well-organized pantry. If everything is neatly arranged and labeled, it's much easier to find what you need when you're cooking up a storm. Moreover, secure storage is essential. We're dealing with potentially sensitive information, so we must protect it from unauthorized access or corruption. This is akin to keeping your pantry locked to prevent pests from getting in and spoiling your food. In essence, data collection is the process of gathering the ingredients for our data science recipe, while data storage is about keeping those ingredients safe, organized, and ready for use. Both are fundamental steps in the data science lifecycle and set the stage for all the exciting analysis and insights that follow. A secure and efficient storage system is crucial for quick retrieval and processing of the collected data. Once the data is stored, the next step is data preparation. This phase is often considered the most time-consuming part of the data science lifecycle, but it is absolutely essential for the success of any data science project. Imagine data as a raw diamond, right out of the mine. It's probably not very shiny yet, and it might even have some dirt and rock attached to it. This is what raw data often looks like. It's messy, it's unprocessed, and it's not ready to be analyzed. That's where data preparation comes in. Firstly, we have to handle any missing or inconsistent data. Missing data can cause significant problems when we try to analyze it, leading to inaccurate or incomplete results. There are several strategies to deal with missing data, such as ignoring it, filling it in with a default value, or using statistical methods to estimate a suitable replacement. Inconsistent data, on the other hand, might include things like different spellings of the same word or dates in different formats. This can be fixed by standardizing the data, ensuring that it's all in the same format and that similar things are represented in the same way. Next, we need to remove any duplicates. Duplicate data can skew our results, making it seem like there's more of something than there actually is. This is often as simple as identifying and removing any rows in our dataset that are exactly the same. The process of normalization is another important aspect of data preparation. It involves adjusting the values in the dataset to a common scale, without distorting the differences in the ranges of values or losing information. Finally, data type conversions may be necessary. For example, changing a string of numbers into an actual numerical data type, or converting categorical data into a format that can be understood by our analysis tools. Once all of these tasks are completed, we're left with a dataset that's clean, consistent, and ready for analysis. The goal of data preparation is to create a clean, high-quality dataset that yields accurate and reliable analytical results. After the data is prepared, it's time for exploration and visualization. This phase of the data science process is like a thrilling detective story. Our protagonists, the data scientists, delve into the clean data to unearth its secrets. They explore the data, not with a magnifying glass, but with powerful tools of statistical analysis and data visualization. To understand the data's patterns, characteristics, and potential anomalies, data scientists utilize an array of statistical techniques. Descriptive statistics provide a summary of the data's central tendency, dispersion, and distribution. Inferential statistics offer insights beyond the data at hand, enabling predictions about a population based on a sample. However, statistics, while powerful, can sometimes be abstract. That's where data visualization comes into play. By translating numbers into visual formats like graphs, charts, and plots, data visualization brings data to life. It allows us to see the big picture, spot trends, and identify outliers that might otherwise go unnoticed. Let's imagine we have a data set of global temperatures. A simple table of numbers won't tell us much at first glance, but a line graph showing temperatures over time, that could reveal a trend of rising temperatures, a clear visualization of global warming. Or consider a data set of a city's population demographics. A pie chart can instantly show the proportions of different age groups, ethnicities, or income levels. A heat map could visualize the population density across different neighborhoods. Data visualization is more than just pretty pictures. It's a powerful tool that aids in the understanding and interpretation of complex data sets. It helps data scientists and anyone else looking at the data to grasp what the numbers are saying. So you see, the exploration and visualization phase is not just about crunching numbers. It's about unearthing the stories hidden within the data and bringing those stories to light in engaging, understandable ways. But the journey isn't over yet. After exploring and visualizing the data, it's time to build models and analyze the results. That's the next exciting chapter in our data science story. The exploration and visualization phase helps data scientists understand the data's main features and potential anomalies. With a good understanding of the data, the next step is model building and analysis. At this stage, data scientists become a bit like detectives, using a variety of tools and techniques to uncover the hidden stories within the data. They apply machine learning algorithms, statistical models, and other techniques to extract meaningful insights. Each of these tools serves a specific purpose and is chosen based on the nature of the data and the questions we're seeking to answer. Machine learning algorithms, for instance, can be used to predict future trends or classify data into different categories. These are particularly useful when working with large data sets where manual analysis would be impractical. Statistical models, on the other hand, provide a more traditional approach to data analysis. They can help identify relationships between variables, test hypotheses, and even forecast future occurrences. But it's not just about finding patterns. It's also about verifying their accuracy. This is where validation techniques come into play, ensuring that the insights derived from our models are reliable and reproducible. The ultimate goal of this phase is to build predictive models. These models, based on the patterns and relationships identified in the data, can make accurate predictions or classifications. For example, a predictive model could forecast sales for the next quarter, predict the probability of a customer making a purchase, or classify emails as spam or not spam. The model building and analysis phase is all about extracting meaningful insights from the data. The final key aspect of data science is the communication of results. This stage is where the magic truly happens. All the hard work of collecting, preparing, exploring, and analyzing data culminates into this moment. Here, data scientists communicate their findings and insights to stakeholders in a way that's easy to understand and act upon. This is not just about spewing out complex numbers and jargon. It's about telling a story with data. This story could be told through comprehensive reports, engaging visualizations, or impactful presentations. These mediums help translate the complex language of data into something more digestible, something that can drive informed decision-making. The importance of this stage cannot be overstated. Why? Because it's the bridge that connects the world of data science with the real world. It's what allows businesses to harness the power of data and use it to their advantage. And this is why data science is so pivotal in today's digital era. With the explosion of data, every field, be it finance, healthcare, or marketing, needs data science to make sense of it all. It's the compass that guides us through the vast ocean of information, helping us make data-driven decisions. Remember, data science is a dynamic field that constantly evolves as new techniques and technologies emerge. If you're interested in data science, there's always something new to learn.